solving one-step equations with addition and subtraction. When we refer to equations, we're referring to mathematical expressions that include equal signs. In algebra, we work with many types of equations that include variables within them. One of the biggest ideas of algebra, really the point of algebra, is all about what's called solving for these variables. The purpose of solving equations is so that we can figure out the values of an unknown variable. In order to solve an equation for a variable, what we need to do is to manipulate or change the equation so that the variable is the only thing left on one side of the equal sign. To do this, we use inverse operations, or in other words, opposites. Addition has an inverse operation or opposite of subtraction, and vice versa. The inverse operation of multiplication is division, and the inverse of division is multiplication. Solving equations becomes possible because of two very important properties in algebra. The addition property of equality states that for any numbers a, b, and c, if you start out with an equation and a is equal to b, then a plus c must be equal to b plus c. In other words, if two things are already equal to each other, you can add whatever you like to the equation as long as you add it to both sides. This property also applies to subtraction. If a equals b, then a minus c must be equal to b minus c. You can make any change. You can add or you can subtract any number to an equation as long as you add or subtract it to both sides of the equation. Solving equations is actually a very common practice for everyday life, for all of us. But because we do the math in our heads, we don't really think of it as being algebra. Imagine you're at a restaurant with some friends. You order a meal and a $3 drink. When you get your bill, the total cost of everything was $12. So, how much did your meal cost? If you said $9, then you were correct. The meal cost $9. Without even knowing it, you were using algebra in your head. The meal plus the $3 drink cost $12. In solving an equation to figure out an unknown value, we always ask three questions. What's on the same side as the variable? In this case, 3 is on the same side as the variable. What is it doing to the variable? The 3 is adding. So in order to solve, we need to do the opposite. The opposite of addition is subtraction. But don't forget that if you want to make a change to an equation, you have to do it to both sides of the equation. We say that when you add 3 and subtract 3, it cancels out, leaving only the m. 12 minus 3 gets us 9. So the meal costs $9. Gift cards are very commonplace in restaurants today. But it's really important that you know the original bill so that you can tip correctly. Say you're at a restaurant and you use a $5 gift card. Once that's taken off, your new total is $26. Well, how much was the original bill? If you were able to figure out this calculation, $31, and you were using algebra and solving equations in your head, the original bill minus the $5 gift card gave us a new total of 26. To solve, what's on the same side as the variable? 5. What is 5 doing to the variable? Subtracting. So we must do the opposite. The opposite of subtraction is addition. B, or the original bill, is equal to $31. Here are two more examples. On the left, x plus 4.3 equals 2.8. To solve, what is on the same side of the equation as x? 4.3. What is 4.3 doing to x? It's adding. So in order to solve, we must do the opposite. We subtract 4.3 from both sides of the equation. On the side of x, 4.3 cancels out, getting x by itself. On the right-hand side of the equation, 2.8 minus 4.3 equals negative 1.5. The solution to our equation. The problem on the right, negative 2 plus x equals 1, looks a bit confusing because the variable comes after the number. Whenever this happens, remember that order really doesn't matter because of the commutative property. If you're more familiar, you could switch the two numbers. Put the variable first, the number second. When making changes like this, what is crucial to remember is that the sign in front of a number needs to stay with it. Putting a plus sign in the very front isn't necessary, but you can do it anyway. Once you've rewritten the problem as x minus 2 equals 1, what's on the same side as x? 2. What is 2 doing to x? It's subtracting. So we must do the opposite. If you add 2 to both sides, you cancel out the 2's. 1 plus 2 equals 3, the solution to our equation. Here's some more one-step equations to try using addition and subtraction. Try them and take them to your teacher for corrections.